Uh, Welcome you all. Now, one by one, we will be discussing all those questions. Those are very important questions we have already delivered lecture about in our previous lecture. So, the question that we are now discussing is the Gauss's law. It is a statement and its proof. This is the question sometimes being asked in the board exam. State and explain Gauss's law or Gauss's theorem. So let us discuss the Gauss's statement. It states that the total electric flux through a closed surface in a vacuum is 1 over epsilon naught times the net charge enclosed by that surface. Now, what does this statement actually mean? It shows that a flux denoted by phi is equal to 1 over epsilon naught times the charge enclosed by the surface. This is a mathematical form. This is a statement. Now, how we can understand it? असल में है क्या ये हम कैसे समझ सकते हैं कि what actually phi is equal to 1 over epsilon naught times the magnitude of charge. What actually it means? Say suppose if we have a closed surface called a Gaussian surface containing charge q, then the flux will be equal to 1 over epsilon naught, a constant term, into magnitude of this charge. Suppose you have a Q is equal to 2 coulomb here, then you can write phi is equal to 2 coulomb divided by epsilon naught. Substitute value, you get the answer. Suppose you have another object, another body, say plus Q charge and minus Q charge. The formula is Q is equal to 1 over epsilon naught net charge enclosed by the surface, a total charge. Here you have to find out the net charge. Here net charge is equal to plus Q and minus Q, that is equal to 0. So the flux here will be equal to phi is equal to 1 over epsilon naught times naught, 0 is equal to 0. So it is no flux. When the body is neutral, there is no flux. Gaussian surface will not have any flux on that. So you need to have a charge imbalance inside, or you need to have a charge inside a system, inside a closed body. Suppose another body is another example. I have a charge plus this plus Q here and plus Q here. What will be the flux? As per the statement, the net charge enclosed by that surface, this surface is not containing any charge. Charge is outside. यहाँ पे जो charges है वो outside है. क्लोज्ड सिस्टम के अंदर कोई चार्ज नहीं है और कंडीशन जो है कि चार्ज जो अंदर है 1 by epsilon naught times that magnitude of that very charge. So here also phi is equal to 1 over epsilon naught, because there is no charge inside the system, that is equal to 0. So phi is equal to 0. But if the total charge, net charge is equal to 0, the system is neutral, balanced system, then there is no flux at all. If the charge is outside the closed surface, outside the Gaussian surface, even then the flux is 0. If the charge is given, say plus Q or minus Q, then you can calculate the charge. Similarly, if we have, these are the examples. Similarly, if we have a body Q, charge Q, what will be the flux? Phi will be equal to 1 over epsilon naught times Q. Suppose if this surface is enhanced, suppose we enhance the surface, we increase the surface, Gaussian surface in Q, then even then phi is equal to 1 over epsilon naught times Q. Here, this means the shape, the size, the flux is independent of the size, and here indicates that the flux is independent of the shape. The flux that is calculated by using Gauss's law is independent of the shape and size of the body of the closed surface. Suppose if I put the charge here plus Q, then flux is again, phi will be again 1 over epsilon naught times Q. It also is independent of the charge distribution. Closed system के अंदर charge distribution कैसी है? It is independent of that. Flux is independent of that. Flux also independent of the size of the object. यहाँ पे छोटा सर्कल था, यहाँ पे बड़ा सर्कल है. Flux same निकला. Even also flux is independent of the shape ऑफ द बॉडी। तो तीन कॉन्सेप्चुअल क्वेश्चंस आप निकल गए, इज इंडिपेंडेंट ऑफ शेप ऑफ बॉडी, इज इंडिपेंडेंट ऑफ द साइज ऑफ द बॉडी, एंड इज इंडिपेंडेंट ऑफ द डिस्ट्रीब्यूशन ऑफ द चार्ज। चार्ज कैसे डिस्ट्रीब्यूट होगा inside the closed system? The flux is independent of that. Mostly charges are distributed symmetrically, but here we discuss it that in a closed system, wherever the charge will be, the flux will be equal to Q over epsilon naught. This was a statement regarding the Gauss's law. Now, how to find out the proof for a Gauss's law? Before going to prove the Gauss's law, let's discuss one thing, that flux is also defined as phi is equal to E dot D, E dot A, say dA, I can add small area element or add A, suppose. The dot product of electric field, and area vector. Dot product of electric field and area vector. Suppose if this is a closed system, I insert a charge in the closed system, then obviously if it's a plus Q charge, the electric field will be outwards, because the field lines are away from the plus Q charge. From plus Q charge, field lines are always away from the charge. So plus Q charge in this closed surface, and I just closed it. Now the area, surface area, this take is a Gaussian surface. You have to calculate the area and what is the direction of area, because you have an angle between E and A. Phi is equal to EA cos theta, and cos theta is angle between E and A. The direction of this area vector, this area is perpendicular to this surface. जहां जहां पे भी एरिया है उस एरिया पे परपेंडिकुलर डालना है, आउटवर्ड ड्रॉन नॉर्मल. The vector drawn outward gives the direction of the area, this very area. Outward drawn normal on this very surface gives the direction of this very area, and outward drawn normal on this very surface gives the direction of this area, and outward drawn normal on this surface gives the direction of this area. It means इस एरिया का जो डायरेक्शन होगा that will be away like this, इस एरिया का डायरेक्शन होगा that will be like this, इस एरिया का जो डायरेक्शन होगा that will be in this direction, इस एरिया का जो डायरेक्शन होगा that will be in direction, इस एरिया का यहां से होगा. अगर ये सफिरिकल होगा तो सफिरिकल में आप उस पर पिन लगा दीजिए, जहां जहां से पिन जा रही है ऊपर की तरफ वो उसके एरिया की डायरेक्शन दे रहा है. सो इलेक्ट्रिक फील्ड बाहर की तरफ है, एरिया वेक्टर भी बाहर की तरफ है यहाँ पे. इट मीन्स अगर एरिया वेक्टर यहाँ की तरफ जा रहा है, बाहर की तरफ जा रहा है, एरिया वेक्टर इज आउटवर्ड्स, और इलेक्ट्रिक फील्ड इज आल्सो आउटवर्ड्स, इलेक्ट्रिक फील्ड इज आउटवर्ड्स, एरिया वेक्टर इज, थीटा इज 0. So when theta is 0, phi is equal to E into A into cos 0. Cos 0 is 1. The flux is maximum, E dot A. Flux is maximum when E and A are parallel. Means electric field moving away in case of positive charge, and area vector outward drawn normal moving in the same direction along the direction of E. So phi is equal to E dot A. You have to remember it. Now suppose how to calculate, how to prove this Gauss's law. We have a sphere of radius r, or at a point at the surface at a distance r, the direction of electric field will be along this direction. We have to find out the flux as per this expression. So the E is the direction of electric field. यहाँ से ऐसे electric field होगा, यहाँ से ऐसे electric, हर जगह से बाहर की तरफ electric field होगा. Now we have to find the surface area of the sphere. The surface area of the sphere, and we know the surface area. If let us consider a small area element dA, this is dA. Its direction will also be along E. The direction will be same as that of E, because स्फीयर में जब आप सेंटर पे चार्ज रख रहे हो, स्फीयर में सेंटर पे चार्ज रख रहे हैं आप, तो इलेक्ट्रिक फील्ड बाहर की तरफ जा रहा है ऐसे ऐसे, तो ऑब्वियसली इस एरिया का वेक्टर भी बाहर की तरफ है. यहां से इलेक्ट्रिक फील्ड ऐसे जाएगा, इस एरिया का वेक्टर भी यहां से ये एरिया वेक्टर बाहर होगा कि वो परपेंडिकुलर होगा. हर जगह हमें परपेंडिकुलर लाइन डालनी है आउटवर्ड्स, दैट गिव्स द डायरेक्शन ऑफ दैट वेरी एरिया. सो हियर the direction of this small element is along the direction of E, that's this electric field produced by the charge Q at the center of the sphere. So you can write the small electric flux d phi on this very surface area, on small area dA, is equal to E dot dA, because E is the electric field is a constant of this very surface, because the same distance r at every point which is at a distance r contains the same electric field. So electric field in this is constant. So this is the small current, this small area element containing electric field E, and the dot product of E dot dA is equal to d phi, the small flux. So d phi is equal to E dA cos 0 degree, because dA is the same direction as that of E. Theta is 0, it is 1, cos 0 is 1. So d phi comes out to be equal to E dA. Now this is flux, this small electric flux due to a small area element. Now total, we can integrating the above equation, integrating the equation above, we get integral d phi is equal to integral dA, that's equal to E into dA. Obviously, this dA is a small surface area element. If I take another element, if I take another element, if I take the elements from the whole sphere, we get the total area of sphere. So integral dA, small area element, integration of those small area elements gives a total area of sphere. This portion gives the E into area of sphere. So this is equal to E into area of sphere is 4 pi r squared. So you get flux. This is flux. Integral d phi is phi. So you get phi is equal to E into 4 pi r square. Using Coulomb's law, you can also state here that that is a point charge. The point charge producing an electric field at a distance r is given by, say, E is equal to 1 over 4 pi epsilon naught q over r square. This is electric field due to a point charge. This sphere containing a charge q at a center, and the electric field at a distance r is given by the electric field due to a point charge, that's E is equal to 1 over 4 pi epsilon naught q over r square. Substituting here, so phi is equal to 1 over 4 pi epsilon naught q over r square into 4 pi r square. R square cancels, 4 pi cancel. Phi is equal to q over epsilon naught, which is a required theorem of Gauss's law and Gauss's theorem. Okay, simplify it very simply. Let's consider the sphere containing charge q. This is a Gaussian surface. The electric flux phi is equal to E dot A. You know the angle, that is 0 degree. Now it's a proof. D phi is equal to E dot dA, small electric flux produced by the small area element E dot dA. D phi is equal to E dA cos 0, because area element is the same direction as that of E. So you got E dA cos 0 is 1. So then integrating for a whole sphere, you get the area of sphere is 4 pi r square. You know E is electric field also due to a point charge. You can substitute it, and then you can phi is equal to q over epsilon naught. Let us go to the next lecture, the application of Gauss's law. Thank you.